Good afternoon. This is the image that I'm going to start talking about. Can I just do, because this image is so deeply ingrained to my own history, can you just put your hand up if this looks familiar to you? Okay, that's good. It's actually kind of refreshing that not a lot of hands went up. This is the result of a collaborative partnership. Charles, Jeffrey, and Colette at Bangert worked together to make this drawing, and they worked together to have a computer art practice. I'm going to start by reading their quote about their practice, and then after this quote, I'm going to proceed into doing something like a close read, but in kind of a cold read kind of way. As you heard, I come from RISD, so this idea of like a close read or like a listening crit is part of my wheelhouse, right? So in an art school context, a listening crit is when the artist doesn't present, but others read the work, and the artist's role is to listen. So this is basically like saying I'm giving myself license to read this from an ahistoric, potentially disrespectful perspective to the artists. So this is what the artists say. We use the computer as a traditional drawing medium. The resulting drawings are to be seen, to hang on a wall, to communicate. They are not just examples of computer technology, not just geometry, not just mathematics. We ask this new medium, questions and get new and old answers. I do want to set the stage. I can do this a little bit less because Sean earlier mentioned a little bit when he was talking about the Munich project, the Penplotter era, in which there were no screens that showed graphics. That's kind of an important element of late 60s, early 70s computer art. To see graphics, you were writing code to operate a pen plotter. That's the way I practice and I teach almost exclusively, is computer code to operate a same kind of pen plotter. They move in an x-axis and a y-axis. Sometimes there's a little bit of Z play in there with variable pressure, but it's physically moving a pen, and that pen is making contact with paper. And so I rotate it. Don't do that at home. I give myself license to rotate it because I know that this is a drawing that the artist looked at from the top down on a flatbed pen plotter. And I think the richness of this drawing comes from a sort of interplay of flatness and depth, as though you're looking down at something in perspective. So before I dive in, should I dive in a little? Okay. Let me say one other thing about what I know about this. This was programmed in Fortran using a plotter like you saw. And so the last caveat is I have not seen the code, right? So I have to do a little bit of forensics on this drawing to kind of decipher it. So let's just go right into this. I see two layers, the dark brown and the light brown. I presume that the dark brown came first, right? The dark brown is the layer that seems to sort of compositionally take over the page, and the lighter brown sort of reads to me as a layer that is meant to have an interplay, a sort of participation in the fuzziness or the disruption of the underlying layer. I suspect these are modular lines. I suspect there is a function or equivalent set of code for each stroke section. And I suspect that same function was deployed over the course of the entire drawing. The thing that makes that special is that visually there are many different kinds of lines here, right? So you could easily do a kind of classification system of the different kinds of lines. The ones that appear to have a loop, the ones that appear to have a single arc. I suspect those are all fundamentally the same algorithmic structure. Now, what excites me about this even further is that the lines are calibrated beyond the sort of safe spatial territory of that modularity. So I think this drawing works particularly well because it's not possible to clearly draw a bounding box around each linear module, right? They bleed into each other. There are even moments where visually, especially like on the left side there, it becomes impossible to perceptually isolate the individual line. You see them as tone only. But yeah, it steps back from being a completely tonal drawing. There are other places where the loopy lines register as a figure. My second conclusion about this drawing is that there is a spatial order to this as a two-dimensional space and a sequential order to those lines. So I believe those lines are ordered in sequence. Like, let's say there are 1,000 lines. I believe there's a logic to number 500 versus number 1 as though they were placed in order, and a secondary logic to where they exist in X, Y, Z space. Third conjecture is that there is some randomness here. I suspect that that randomness occurs on multiple levels of these scripts. I suspect that the randomness is both linked, sort of lives inside the individual function of the line and the position of that line in space. I lost count. Am I on 4 or 5? Whatever. My next conjecture is that there is absolutely, for sure, no 3 dimensions in the structure of these lines. Even as we see this as, oh, and by the way, the title of it, yeah, I should be respectful. The title of it is A Large Landscape. So I think that suggests very clearly that we're seeing this as a kind of growth, right? Form that is sort of planted there in the earth. But I'm fairly certain that the third dimensional is entirely perceptual, and the logic and the structure of this is entirely two-dimensional. I know that they were looking at this as though it was a three-dimensional landscape, even as though they were programming it completely in 2 dimensions. Now, the one most special secret observation and conclusion I have, I saved for last. And probably the ones I've articulated so far weren't that surprising to you, but a really special moment to me. You're not seeing my cursor, all right, but I can describe this. Do you see how at the very bottom row on the left, there's a gap there? Why is that? Now, there's a couple of possibilities there. The most immediate one is that there's some sort of clipping algorithm that says, you know, for whatever reason, if a line segment is predominantly below a certain threshold, the whole line goes away, which is an artistically very sensitive thing to do. Instead of trimming any lines, you make a kind of computational analytic judgment about whether that line should be mostly in or mostly out, and if it's mostly out, it just goes away. However, I don't think that's exactly it, because if you look at the corresponding area above, there is, sort of in that same horizontal datum, there are extra lines at the top. So what that suggests to me is that in the structure of the code for this image, this is not a sample of an infinite Cartesian two-dimensional space, but this is a bounded two-dimensional domain, like a screen, in which, let's see, I'll just, probably this was a modulus operation, right? So things that went off the bounds were shifted to the other side. So this is an inherently computational condition in which it's not a slice, but a space that has limits. Or like you go, you know, like the fish screensaver, right? Fish travel off to the left and they appear again on the right. That kind of sensitivity to me is something that I put an amazingly high premium on, especially now as I try to pivot into the domain of architecture or the subject of architecture. I tend to find it very valuable to look at computer artists sometimes instead of computer, I can't say computer architects because that means something else, but architects that were using computers. Because the tendency of architects often is to just sort of produce an exhaustive set of potential drawings and have discipline in the complete set. This to me is a sort of discipline in the crafting of the code relative to this output, right? That there was an entire world that existed in this drawing, a world that can sustain what happens when something goes too far off the page. It's not really going too far off the page, it's just moving in the world. Say one more thing about the light orange layer. Notice that there isn't any light orange on the right. So this is the sort of most macro level of control that's going on here algorithmically, which is, I believe that there is a computational structure that must exist, as I mentioned, for the line. I believe there's a computational structure that must exist for the world. And then I believe that this is actually two different worlds, and then there's a sort of meta computational structure that exists in the deployment or the marking of those worlds. So I think it's very, although it's hard to see, I'm fairly certain by zooming in a little bit that the light orange layer is the same quantity of information as the dark orange layer. So it's not a truncation, but different sort of parameters of those lines being marked. Okay, I held out as long as I could from showing my own work. Here is that phase of this presentation. The one thing that the Bangerts did not do in that particular drawing, they did it in a lot of their work, is utilize the fact that a straight line segment drawn by the Penplotter also betrays some of the structure of the underlying lines. So if they used a pen in their Penplotter that was moving a little bit slower, or the apparatus required a pause between the instructions of different segments, it might betray the fact that those curvy lines were actually all 7 segments of lines, right? So they purposefully are moving the pen relatively fast, so that when you get a straight line segment, you're not seeing the fact that it was actually 1, 2, 3, 4, 5, 6, 7. I use that often to my advantage, where the segmentation of lines or a pause in the plotter movements articulates a moment where the ink is bleeding ever so slightly. The Penplotters, again, just to be clear, the physical felt tip pens, if you leave them hanging around, the ink bleeds out. And it's that bleeding that really makes the fact that they didn't have graphic screens, right? In the sense that we know bitmap image formats. To me, them not having that is an essential limitations. In the discussion earlier, they were talking about the essential role of constraints in a creative process. I can tell you for certain that looking at pixels on a screen of this drawing undermines my crafting of the drawing. Sometimes I have to look at pixels. How many times have you ever heard someone say, sometimes they have to look at pixels? It's a very weird thing to say, but pixels are really my enemy in this discipline. By the way, I stopped subscribing to the discipline of architecture. I'm out of that game. I think, by the way, Joseph is too. Joseph, or I shouldn't say it, but clearly Joseph is crafting a discipline, right? There's a discipline to his work. And I probably will talk about this, but Joseph and I both have to address the problem of our own discipline in the context of education, the education of professional architecture students. So it's very, very tricky to put my money where my mouth is if I'm saying I'm checked out of the discipline of architecture, but I'm interested in educating architects with discipline. How do you do that? It's very, very tricky. And I don't think that everyone has to have a Penplotter and valorize late 60s, early 70s technology. But I think everyone has to have some kind of discipline, and there's a way to do this, to extract your discipline by operating with these tools, which is why I'm also totally cool with the idea of running like the workshop that I'm going to do tomorrow about making things with Penplotters. So when you have those, the segmentation of marks, you can also do kind of absurd things like at the time of the decision about which pen to use, you can make little switch ups with particular ease. Again, I think very equivalent to Joseph's return to the equation when that's appropriate. I can return to the underlying geometry, or return to the machine code, or return to the forces of the drawing as necessary. Let me talk for a minute about what the Bangerts raised, these we asking it the medium new questions and getting new and old answers. What are those new and old answers? And I think what was new and old and relevant in, I believe it was 73 when that quote was articulated, what was new and old and interesting then is the same thing that's new and old and interesting now, in my opinion. And so I'll try to list, I have notes for this because I don't want to miss one of those. Depth, new and old, interesting problem. Did everyone see in the exhibit, there's a drawing, I was talking to Daniel about it, called Magic Carpet, Flying Carpet, yeah. It's in the table in kind of the center area, comes from the MIT archives, and it's unknown what is the underlying computational structure of that image. The biggest debate, I think if we had like a debate, like we could have like two podiums set up, and I would be at the podium that said that's a 2D structure, right? There isn't a third dimension in that, and I think Daniel might be at the podium that's like, no, I think there is a surface there. So this territory of dimensionality, I think, is hugely productive. The other territory that's hugely productive, that unfortunately had a weird relationship to the discipline of architecture, is the role of surface. For us, surface modeling comes in at a relatively late time, but surface in computer art was there way early. This idea that you aggregate lines together, and certainly I had some conversations with others earlier, it certainly was present in pre-Renaissance engraving work, right, where very dense lines work together as a set of hatches to articulate complex surfaces. So depth, surface, and then if we, here's another surface one. Again, like I promise you, there's no third dimension here, right? You can't unsee these bulbous, cloudy things, but that's entirely in your mind. And of course, it's entirely in my mind also as I calibrate the drawing. Yet another surface starting to be articulated, and as that surface is calibrated and controlled, you can use those surfaces to start to define volume. I'm going to get to the next topic, which is edge. But let me say one more thing about surface. This is a cartographic technique for articulating surfaces that really uses orthographic projection on the idea that there is a standard length of line that gets deployed on a three-dimensional surface. And when it's orthographically projected, the line changes length depending on the slope of that surface. So it's sort of like cartography 101, making maps of Earth and stuff. Name of an interesting course. But there's something for me to be learned as an architect from looking at computer art that represents no surface, that would seem to represent a surface, that allows us to actually represent surfaces in ways that might lead to things other than that surface. So again, back to that morning discussion, which I think was awesome. I'm totally in the representation team, not the visualization team. Looking a little closer, same fundamental algorithm, same positioning of an underlying surface, same deal about orthographically projecting, but the pen plotter is here in a way that kind of disrupts it. This drawing is too big for the lifespan of a single pen, so the pen is depleting as it goes. So you introduce the nature of time into the drawing. Yet another from that same era. So now we're into some territory of student drawings, students of mine at RISD. And what I try to set up in a studio setting is an opportunity for students to take these ideas of depth, surface, and edge, and convolve them together in some way. Most of them have at least the opportunity to use a pen plotter. And my opinion basically is that whatever you do with lines, if it has anything related to depth, surface, and edge, you're on the way to an architecture. And you're also on the way to a drawing that functions as an architectural object. RISD's kind of a safe space where you don't ever have to make buildings if you don't want to. And that was it's a little obscure. This is a student named Lena Chen. This is a student named Chi Go. Both of them are looking at oscillating between whether you have content that gets marked and whether you have marks that constitute content. So now we're starting to get into that territory of like edge, the topic of the edge. This is a student named Ziyu Su, who's looking at the corner condition as like a limit condition. So instead of the edge being like the boundary or the border, the edge is the contentious corner. Long history of like, does this play with the traditional corner problem as we know it? There's a longer answer to that question, but the short answer is yes. All corner problems are related to all other corner problems, Renaissance courtyards or otherwise. What happens when you draw a rectangular prism and then draw lines that could be a different but related and conflicting rectangular prism? And now I'll kind of wrap things up with a kind of plea for a return to drawing in a deeply historical sense of the term drawing. I forgot to ask whether this was being recorded. Am I being recorded?
You are.
Okay. All right. So this is like the slightly more sensitive version. Does everyone know about the Yale Symposium, Is Drawing Dead? 2011, 2012. The consensus among the participants in that symposium was that it was essentially like a bunch of different ways of saying, of course not. And my answer is, of course, yes. Drawing died a long time ago, before people started even asking whether drawing was dead. It died before the drafting table. We really haven't been drawing in the discipline of architecture since shortly after the Renaissance. Most of what exists for us on paper or in 2 dimensions is a model that's flat. And if I had to have T-shirts made, they would say something like, "Your 2D thing probably still isn't a drawing." So for me, a drawing means that it requires a crafted and disciplined deployment of marks or lines or content in a substrate. But once that is deployed, it cannot be edited. So I'm answering your question a little bit. A drawing can never, that's why I like that you asked drawing versus text. A drawing can never be text, and you can never, ever, ever represent or work on a drawing in front of a computer screen. I know that's a little bit over the top, and I don't even totally believe it, but I think it's productive to articulate that, right? The things you print out are not drawings. File print means you didn't draw it. It means you modeled it. So, time? Okay. I think you can draw with fabric, right? And this is a sort of return to a true drawing, right? You can't, once you stitch something, you can't unstitch it, or you can't edit the stitch. The stitch affected the substrate fabric. So this is a drawing that takes form, right? It starts to build up form. It can be representational, but it's also sort of effective. And my big project is to push this kind of object drawing at the discipline of architecture.